Having looked now at the wideband information, we have the opportunity, or the necessity actually, to recalculate the same information with the same methodology, but now on a high resolution spectra. So instead of delta, there are 0.4 hertz steps. That's the high resolution. Instead of being 4 bands, it's 0.4 hertz steps. And you can see as you open this module, it might ask to run the Loretta information, so you'll be aware of that the first time, that this is a recalculation of the data and a new approach. It lands on the overall maximum of Z power. You have multiple different measures through which you can observe the spectra at each of the sites, at FP1, the whole spectra, at F7, F3, all at a glance. You can see that distribution here, in this case, presented in Z values. You can see also that, as is common with Brain DX, a legend at the top. We have the vertical lines are for 10 hertz dividers, and you have a green line which is negative 1.96 standard deviations, and a red line with positive 1.96. Anything within is within norms. And then the outliers, when we open the software, it opens directly to that greatest outlier, which is found to be in red at FP1. We know our range over here. So, always looking for those headers. You can see that in general this is an overactive spot, and in what would otherwise be apparently a more normal type of a brain pattern. But that's just looking at it in Z power. That's the microvolt squared normatized. What if we were to look at it in the Z-score scale in relative? Yes, it still is. It still is a valid peak here, actually the peak, again at FP1. And then now let's look at it with a different calculation. Instead of being microvoltage, it's the current source density calculation that is necessary for us to produce Loretta. Let's have a look at that. You see a different location for this phenomenon. You can zoom out. You can use this arrow to check that out. I just did with the up arrow. I moved my scale from 0 to 3 to 0 to 4 now. And let me go back up to Z power and see that the location is a little different. We learn a lot by having different perspectives. These three calculations are very much in that sense of perspective. I'm going to go back to 0.4 and I'm sorry, 3Z. I'm going to go ahead and print these out one at a time, which is just something that I have a preference for, is to have these three optics of the Loretta. But as you can clearly see, there's a lot more that one can do. We can look at the magnitude values, and that's a different scale. We can also look at the magnitude of the cortical. We can even look at what would be the expected value for that age at that frequency slice. So there's a lot of different views that we can discuss further, but right now the more common uses with Z-scores. And I still want to discuss this spectra here. So when I click on something that's interesting me for a morphological reason, it's oftentimes found in Loretta, something, oh wow, this is very much an outlier. -3 there in the occipital region. And I can sort of scan through it, and I can see that it starts to decrease at 16 hertz, and it keeps on going through. So we can see a fluid band appear, 16 to 24 hertz, the occipital region, or more likely whatever Loretta is going to find that to be. We'll see that again in Loretta, because this is a Loretta calculation. In other words, this is the current source density calculation.